So question 10, an arithmetic progression has a first term of 5 and a common difference of -3. Now the first term is 5 and this is your first term. What will be your second term? So 5 minus 3 would be 2. What will be your third term? 2 minus 3 would be -1. What will be your fourth term? -1 into -1 minus 3 would be -4. So these are your term where the difference is -3. Now find the number of terms such that the sum of n terms is first less than -200. Now let's suppose what will be the sum of the first three terms. So 5 plus 2 minus 1 equals to 6. And the formula for the sum is n upon 2 bracket 2a plus n minus 1 into d. Now n is your how many terms? So we are taking 3 terms. So this would be 3 upon 2 bracket a is your first term, 2 into 5 plus 3 minus 1 into difference is -3. So 3 upon 2, 5 plus, now 3 minus 1 is 2, 2 into -3 is -6. So 5 2s are 10, 10 minus 6. So 3 upon 2 into 10 minus 6 is 4. So 2 1s are 2 2s are 3 2s are 6. And hence proven that this formula holds true. Now what do we want? We want that the sum, that is n over 2, 2a, so 2 into 5 plus n minus 1 and your d is -3 is less than -200. So this is what we actually want. So we have this expression over here. So this would be n upon 2, 10. So n minus 1, so into -3, this would be -3n and plus 3 is less than -200. So n upon 2 bracket 13 minus 3n is less than -200. And 13n minus 3n square is less than -400. So 2 will go over there, it will become 400. Now we have -3n square, so we need to convert this into positive. So we will going to multiply both sides by -1. So this will become 3n square minus 13n. And when we multiply both sides by -1, this less sign will actually become greater into 400. So our equation would be, now let's clear our work. Our equation would be now 3n square minus 13n minus 400 is greater than 0. Now we need to find out factors. Now find the number of terms such that the number n terms is first less than -200. And we need to understand that mn will never be a negative number. So there are n terms. So these are positive terms. So how can I solve this? So there's a formula -b plus minus under root b square minus 4ac whole over 2a. So we have a as 3, b as -13 and c as -400. So we substitute these number in our equation. So -b would be minus into -13 plus minus b square. So -13 square is 169. Minus 4a is 3. C is -400 divided by 2 into 3. So 13 plus minus under root 169. So 4 3s are, so -4. So 1600 into 3. So 12 into 400 would be 4800. That's 4800 divided by 6. So the first one would be 13 plus under root 4800 plus 169 would be 4969 divided by 6. So if I solve this, so if I under root this plus 13, so this would be 13 plus 70.49. So we don't need to do it with negative because 13 minus 70.49 would be a negative number divided by 6. So plus 13 divided by 6, we get 13.9. Now n is, now the n we are getting, n is greater than 13.9. So obviously n will not be 13.9. So the first term in which you get less than minus 200. So this is the expression. So n greater than 13.9. So what will be the first integer? So it will be 14. N would be 14 such that we get the sum that is less than minus 200. So the correct answer is 14. So it's the 14th term because n is greater than 13.9. So what will be the first whole number that will be coming? That will be 14. Now let's do the second part. So a geometric progression is such that its third term equals to 81 over 62.4 and the fifth term equals to 729 over 1024. Now let's suppose our first term is A and R is the ratio. So this is your first term, this is your second term. So the second term would be AR. The third term, so again we need to multiply this by R, this would be AR squared. The fourth term, again we need to multiply this by R, this would be AR raised to power cube. Again, in order to find the fifth term, we need to multiply it by R, so this would be A raised to power 4. So we know that the third term is, so this is your third term, so this is 81 over 64. And your fifth term is 729 over 1024. So AR square equals to this and AR raised to power 4 equals to 729 over 1024. So the first question is find the first term in the progression and the positive common ratio. So first thing first, we find out the this ratio, the common ratio. So simply we can say A R raised to power 4 divided by A R raised to power 2 would be 729 over 1024 divided by 81 over 64. A and A cancels out and R square and R4. So we get this expression R square equals to 729 divided by 1024 multiply by, so this will going to flip now. If you are multiplying, this would be 64 divided by 81. So 729 divided by 81 is 9. So 81 ones are, 729 nines are. And we also need to understand that 10 raised to power 2 raised to power 10 is 1024. And 2 raised to power 6, 2 raised to power 6 is 64. So now 1024 divided by 64 would be 16. So 64 ones are 64, 1024 divided by 64 would be 16. So we get R square equals to 9 upon 16. So R would be, so under root this, so this would be 3 over 4. So under root 9 over 16 would be 3 over 4. So this is the ratio that we are getting. So this is your ratio. Now we just need to find out A now. So A multiplied by R squared. So this would be R squared would be 9 over 16 would be equal to 81 over 64. So A equals to 81 multiplied by 16 divided by 64 multiplied by 9. So 9 ones are, 9 nines are, 16 ones are, 16 fours are. So A we get is 9 over 4. So A we are getting is 9 over 4. So this is for our first part. So we have calculated the first term and the common ratio. Now second part says, hence find the sum to infinity of this progression. Sum to infinity. Now the formula for this is sum to infinity is A whole over 1 minus R. Quite simple. So A is 9 upon 4 divided by 1 minus R. So 1 minus 3 upon 4. So 9 upon 4 divided by 1 minus 3 upon 4 would be 1 upon 4. So 9 upon 4 multiplied by, now if I convert divide sign into multiply, so we need to flip this up. So we multiply by 4. 4 and 4 cancel and we get 9. So if we sum to infinity, we will going to get the number 9. So this is the right answer.